All right, welcome back to another episode of Math with Mr. Young. So today we're going to be working on 4.3, comparing and ordering fractions, decimals, and percents. Our standard is 6th grade number since A, and your objective is that we're going to be able to compare and order fractions, decimals, and percents. Our mathematical literacy is percents, decimals, fractions, compare, and order. All right, to begin with, for 4.3, comparing and ordering fractions, decimals, and percents, our success criteria is that by the end of this lesson, you will be able to rewrite a group of fractions, decimals, and percents using the same representation. You will also be able to explain how to compare fractions, decimals, and percents. And lastly, you'll be able to order fractions, decimals, and percents from least to greatest. All right, we're going to kick this off with our mathematical literacy. By that, I mean our vocabulary words. So just to refresh our memories, a percent means per 100. Remember that percentages are ratios that compare a quantity to 100. And for an example, we have 33%. That means 33 per 100. And that also can be written as 33 to 100, or 33 out of 100, or 33 over 100, or 33 hundredths. Remember, the decimal point, you have 3/10, 3 hundredths. So we have 33 hundredths as a decimal. Speaking of a decimal is on the base 10 system. A decimal number is often used to mean a number that uses a decimal point followed by digits that show a smaller value than 1. So most times decimal numbers are smaller than one whole number, okay? That means that 33 hundredths is less than one whole. So what I mean by that is you have one whole, just like number 1, and we have 33 hundredths. That means that one whole is greater than 33 hundredths, okay? Because 33 hundredths is less than 1. All right. Now, when we look at that decimal point, whenever we move that decimal point to the left, we're dividing by 10 by each jump, okay? So in this case, if we divide it by 10 one time, divided by 10 again, divided by 10 again, so we move the decimal point 3 times to the left, we divide it by 1,000, okay? Now, if we move the decimal point to the right, we are multiplying by 10 each jump. So anytime we move the decimal point to the right, we multiply by 10 more, by 10 more. So in this case, we move the decimal point to the left, we move the decimal point to the right 3 times, so we multiplied by 1,000. All right, so to continue, we have fractions, and fractions are real numbers that represent a part of a whole. A fraction bar separates the part from the whole, like so. So your part is always going to be your numerator, okay? The whole is going to be the denominator. So for an example, let's say that we buy a large pepperoni pizza. And typically, pepperoni pizzas have about 12 slices. For that whole pizza, there's 12 slices. But let's say that we only ate 4 slices out of the 12. So we ate 4 out of 12 slices. All right, so again, we ate part of the pizza. We ate 4 slices, part of the pizza, out of the whole pizza of 12 slices. All right. And now, when we talk about comparing in math, to compare means to examine the differences and similarities. Basically, when we compare numbers, how are they the same? How are they different? We're also looking at the size comparison. Okay, so when we examine the similarities and differences, we look at the numbers, we look at the quantities and the values, and we want to understand which number's bigger, which number's smaller, especially when we order them, when we put things in order in the correct place following the same rule. In this case, when we're told to put the numbers in order from least to greatest, we're putting them in order from the smallest number to the biggest number. Okay, that's the rule here, smallest to biggest. So yeah, let's compare and order fractions, decimals, and percents. All right, so in this example, we're going to be using a number line to order these numbers. Now again, we're going to compare fractions, decimals, and percents. The first one, we have 25 hundredths, and then we have 0.9%, 40%, and then 5/10. So if we look at this, let's make them all into fractions. So 25 hundredths is going to be 25 hundredths. if you have like a percentage like this, 0.9%, knock off the percent sign, and then we divide by 100 by moving the decimal point to the left twice. Annex 2 zeros. So now this is going to be 9 thousandths. Okay. Now we want the denominator to also be 100. So to make the denominator 100, we divide by 10. Okay, and 1000 divided by 10 is 100. And then 9 divided by 10. So 9, move right here. So 9 divided by 10. 10 can't go into 9. Put a decimal point there, annex 0. 10 can go into 90 9 times. 10 times 9 is 90. All right, so now you have your quotient 9/10. So here we're going to have 9/10 over 100. So what this means here, that 9/10 is technically almost one whole, but it's less than one whole. Okay, so just remember that. 40% is going to be 40 over 100, and then of course 5/10 is going to be 5/10. But you make your denominator 100 by multiplying by 10. What you do to the bottom, you do to the top. 10 times 10 equals 100. 10 times 5 is 50. Now we're going to compare 25 over 100, 9/10 over 100, 40 over 100, and 50 over 100. So again, from least to greatest, we're going to number these and put them in order. The smallest number would be 0.9. So if we had a number line, okay, and this is like one whole, here's 0, here's 50, so that would be 50 over 100 would be here, okay, and then here halfway between 0 and 50 is going to be 25, so this is going to be 25 over 100, and then of course we're just going to estimate around here would be 40 over 100, okay, and of course don't forget that 100 over 100 is going to be one whole, okay, because 100 can divide into 100 one time evenly, and of course you have 9/10 over 100, which would be somewhere over here. 9/10 over 100. Okay, somewhere near 0, not quite yet at, I guess, 1 over 100. All right, so there you go. And then the next example, let me just go ahead and cover this. And we have 0, 3/4, 30%, and 1 over 20. Again, so when we compare fractions, decimals, percents, we want to make them all sort of like in an even playing field. So I guess, again, if we make this into a fraction, 0% would be 0 out of 100, or 0 over 100. 3/4. So if we look at that, multiply 4 times 25. What you do to the bottom, you do to the top. 4 times 25 is 100. I'll put it down here. 3 times 25 is going to be 75. Okay. And then 30% is going to be 30 over 100. And then, of course, you have 1 over 20. Multiply the bottom and the top, numerator and denominator, by 5. 20 times 5 is going to be 100. And then, of course, 5 times 1 is 5. So this is going to be 5 over 100. And then from least to greatest again. Okay, so 0, and then we have 100. So here's 50, here's 25, here's 75. So 75 over 100 is going to be here. 0 over 100 is going to be here. 5 over 100 is going to be probably down here somewhere. 5 over 100. And then, of course, 30 over 100 is going to be somewhere here. Okay, so there you go. In this case, this would be the least number, 0 over 100. So 0 over 100 is going to be the smallest number. The next biggest will be 5 over 100. The next large number would be 30 over 100. The next largest, or the largest out of these, the greatest value would be 75 over 100. All right. So there you go. And that's basically all you do when you compare and order fractions, decimals, and percents, putting them in order from least to greatest. All right, thank you. All right, we're going to move on and do the next example. So we're going to compare fractions, decimals, and percents here. Now the first one for A, we have two examples here. We're going to, we want to know which is greater. In other words, we want to know which is larger. Okay. We have 3 over 20, and then we have 16%. So in this case, what we want to do, we have 3 over 20. So we want to make the denominator be equivalent to 100. Okay, it always has to be 100. How do we get from 20 to 100? Well, 20 times 5 would be 100. So 25 times 5 is 100, and 3 times 5 is going to be 15. So 15 over 100 is going to be 15%. Now, according to what we have here, which is larger, 15% or 16%? Well, I'm going to put a circle in there. Think of it this way. If you had a coyote and you had a sheep, and the coyote is probably going to go after the fatter sheep. So there's his nose and there's his mouth. So 16% would be larger. Okay, so 16% is larger. Okay, and then you just answer the question, which is larger? 16% is larger. All right, so again, you have a fraction. We convert it into a larger fraction. Okay, we want the denominator to be 100, and then we converted that into a percent. Now, numbers B, or letter B, we want to know which is greater. You have 79% and then 8 hundredths. So 79% as a fraction would be 79 over 100. And then you have 0 tenths, but 8 hundredths. So this would be 8 hundredths. So which is greater? 79 over 100 or 8 over 100? Well, of course, we have 79 over 100 is greater. Again, the mouth opens up towards a larger number. Again, this is 79%. So this would be 8%. Again, 79% is larger than 8%. All right. All right, so we're going to compare numbers to solve a real life problem. Now, this situation here, the scenario, we have you, your sister, and a friend. You each take the same number of shots at a soccer goal. So again, you're playing soccer, you're hitting the soccer ball into the goal, or kicking the soccer ball into the goal. You make 72% of your shots. Your sister makes 19 out of 25 shots. And then your friend makes 67 hundredths of his shots. Who made the fewest shots? So again, you made 72% of your shots. Your sister made 19 out of 25% of her shots, or 19 out of 25 of her shots. And then your friend, a triangle around that, made 67 hundredths of his shots. Okay, so I color coded it. So you made 72% of your shots. Your sister made 19 out of 25 of her shots, and then your friend made 67 hundredths there. Now again, we have a fraction, we have a percent, and a decimal. So what we want to do is rewrite these using the same value. Okay, remember, fractions, decimals, and percents are all siblings, all the same. They express themselves in different ways, but they're all related, so they're sharing the same information. Now 72% as a fraction is going to be 72 out of 100. As a decimal, it's going to be 72 hundredths. Okay, 19 out of 25. Well, again, if you multiply this times 4, because you want to make the denominator equal 100. Okay, I guess 19 times 4, if you want to do that. 19 times 4 is 76. So 76 out of 100 is really the fraction. Okay, now 76 out of 100 is really just 76 hundredths, or it's going to be 76%. Okay. Then you have 67 hundredths as a decimal. So 67 hundredths as a fraction is going to be 67 out of 100, or 67%. So who made the fewest shots? Again, you made 72% of your shot. Your sister made 76% of her shot, and your friend made 67% of his shot. So you're going to say that, one more time, you made 72% of your shots. Your sister made 76% of her shots, and your friend made 67% of his shots. So this is your friend, your sister, and then you. So again, you're kicking a soccer ball into the net. So again, who made the fewest shots? Well, your friend did. So you're going to say, our friend made the fewest goals in the soccer net. All right. Now again, there you go. We compared fractions, decimals, and percents, and we ordered them from least to greatest and understand, which, I guess we just compared similarities and differences. All right. Now in 4.3, comparing and ordering fractions, decimals, and percents, we did rewrite a group of fractions, decimals, and percents using the same representation. Okay, using the same representation, or rewriting fractions, decimals, and percents. Now, by now, you should also be able to explain how to compare fractions, decimals, and percents, and also how to order them, fractions, decimals, and percents, from the smallest to the largest number. All right, so hopefully you had fun. And again, please ask for help if you need help. This is what I'm here for. I work for you, and utilize your resources. Okay.